The next kind of problem that we'd like to solve is one where we figure out what percent of an object will be below and what percent of the object will be above the fluid when we place it in the fluid. So the object's going to float, but we don't know how much of it is going to be below and how much is above. So we start out by getting the mass of the object and the original size of the object. So this thing is 700 milliliters in terms of its total volume, and it has a mass of 461 approximately grams. Okay, so how do we attack this? We start by drawing a little picture of it. Here's our fluid level. Here's our object. We're supposing that some of it is going to be below and some percentage is above. We then draw our forces. We have gravity and we have buoyancy. We don't know how much of it is going to be above and below the water, so we don't know the volume submerged. So we should start with our force gravity. It was a mass of about 461 grams, so we make it 0.461 kilograms. We're on planet Earth, so we use our value of 9.8. We multiply those out, and we get a force of 4.518 newtons. Okay? That is the force gravity. If we are going to have this thing float, we need the force gravity to equal the force buoyancy. Buoyancy, again, is fluid, gravitational field, volume submerged. So we have 4,518. Del C water, again, is 995. Earth, 9.8. Volume submerged. We set gravity equal to buoyancy because we want it to float. We use our fluid density and our planet, and that will let us figure out how much is below the fluid. When you work this out, you're going to get a really small number because, again, this is in cubic meters. If you multiply by 1,000, you get liters. And if you multiply that by 1,000, you would get milliliters. Okay? So about 463 milliliters will be submerged. Everything left over will be above the surface. To find the percentage, which is oftentimes what we want, hopefully remember percentage is part over whole times 100. So if I want the part that's underwater, it would be 463. The whole is about 700, and I simply work that out. And I get about 66% submerged. If I wanted to know how much was above, I would obviously just do the 100 minus the 66, and that would be 34% above. Okay, let's actually put it in the water and see how it looks. And if you look, you can see it's a little more than half, so it's looking pretty solid in terms of our calculations. Okay, so as this thing sits in the water, it should be about 60-some% under, 30-some% above. All right, so that is the second type of problem you have to be able to deal with, percent submerged.